Hi, this is Brandon Bates, the Math Department at Lipscomb University, here to talk with you about the definition of a function. In this presentation, you'll learn the definition of a function, ways of representing functions, and how to determine if a given set of ordered pairs is a function. Why should we study functions? Well, functions are actually one of the main tools used to communicate mathematics. They're used to express relationships between two or more quantities, and much of higher mathematics is built upon the concept of a function. So, in some ways, functions can be seen as really the language that we communicate with in applied mathematics and higher mathematics. This function concept becomes extremely important. The definition of a function is as follows. A function is a set or collection of ordered pairs. Ordered pairs take on the form x comma y, in which every x value in the set is paired with exactly one y value in the set. The key to this definition is that it's exactly one y value for each x. We call the set of all x values the domain of the function, and we call the set of all y values the range of the function. There are alternative forms of this definition. Some definitions take a rule emphasis, and so we see here a function is a rule that associates every input with exactly one output. Regardless of the form of the definition you use, there are these two key aspects. First off, a function is a set of ordered pairs, and second, every x is paired with exactly one y value. Let's talk about some common ways of representing functions. And it should be noted, these are also common ways of just representing any set of ordered pairs, regardless if the ordered pairs satisfy the definition of function or not. First is writing an equation that explicitly states the relationship between the x value and the y value. For example, if my wife makes twice as much money as I do, then we could write an equation relating her income and my income, and we could say y is equal to 2x, where x represents the amount of money I make, and y represents the amount of money my wife makes. Second common way of representing functions is by looking at an XY table. Some call this a table of values. And going back to the previous example of my income and my wife's income, we can see here some of the ordered pairs that would be present in this table of values. If I make 20,000, she makes 40,000. If I make 30,000, she makes 60,000, and so on. It definitely should be noted that we are only looking at a finite number of the ordered pairs here, and that will be true pretty much anytime we make an XY table. We're not going to be able to write down every ordered pair that corresponds to a function's complete set of ordered pairs. The third common way of representing functions is by graphing that relationship on the XY plane. And so here we've graphed the relationship between my income and my wife's income. Excuse me. Using the x-axis to represent my income and the y-axis to represent my wife's income, we see that at each step of the way, whatever my income is, she has double that amount. If I'm at 2 hundredths, I know that's a weird value for my x's to be labeled. If I make 2 hundredths, she makes 4 hundredths, so on. All right, let's see if we can determine whether we have a function or not when we look at a set of ordered pairs. So first we'll look at y equals 3x plus 1. And we want to know whether that's a function or not. We'll kind of go through looking at a few different representations of this function to come to our conclusion. First, let's just try an x value. Remember that definition of function says for each x, you should have exactly one y value paired with that x. So if we let x be 4, we should anticipate, if we think we're looking at a function, we should anticipate a single y value that makes that equation true. All right, well, when we do that, we get y is equal to 3 times 4 plus 1, which turns out to be 13. So when x is 4, we get a y value of 13. And that matches up to what we were hoping. One x value goes in, and it's paired up with exactly one y value. The question is will that always happen for any possible value of x? All right, so let's take a look at our second representation, the xy table, and just see if it can give us a little more information. So we're trying x equals 0, 1, 2, 3, and 4. Each time that we plug those x values into our equation and find the corresponding y, you'll notice that we're getting exactly one y value paired with each of those x's. So far, it's looking like it's going to be a function. Third, let's take a look at the graph. You'll see there we have the graph of a line. And as we look at each x value and see where the ordered pairs are, you'll notice that every x value only has one ordered pair, or that is only one y value that's paired with it. Okay, and so we've examined sort of all three of our representations, and we can conclude that it is indeed a function. Let's take a look at a second equation. This is the equation x equals y squared. Excuse me. And we want to know, is this a function? So again, we'll kind of go through and just choose x equals 4. Nothing special about x equals 4, just choosing it to plug in. Definition of a function says each x is paired up with exactly one y value. So when x is 4, if this is a function, we should get exactly one y value that makes the equation true. Well, what we get when we let x equals 4 is we get 4 equals y squared, which actually is true if y is 2 and is true if y is negative 2. So we have the following ordered pairs, 4, 2, and 4, negative 2. And so this actually violates the definition of function. We have a single x value, the x value 4, and is paired up with two different y values. Okay, so this is not a function. Let's take a look at the xy table just so we can anticipate what to look for there. When we let x equal 1, we plug in, we find two y values that correspond to x equals 1. And we get that same kind of behavior over and over with this equation. So again, not a function. Graphically, as we look at this graph, we can look at a single x value and note that it has a y value paired with it here. And that same x value has a y value paired with it here. And again, that violates the definition of function. So we would conclude it is not a function.